Okay guys, so this is moles and this is designed more for AS students. Although A2 students can get questions on moles, theirs will probably be a little bit more complicated than this. So if you're an A2 student, this would be good revision, but don't think that this is the extent to what you're going to need to know it. If you're AS, this is the type of question you'll probably get. So with moles, or at least with the long style moles questions, it's all about this diagram here. So here's an elephant and here's a picture of my auntie. This is my auntie Pam, with her, obviously very old, getting on a bit, getting sucked by an elephant on her cheek, like that. So what this stands for is, did my elephant suck my auntie? This is the word mnemonic we're going to use to answer these long styles moles questions. And if you follow this through, you'll get the marks every time. Okay? But you've just got to not miss out any steps. So what I'm going to do is go through what this word mnemonic stands for, and then I'm going to stop for like 10 seconds. Can you pause the video then and write it down? Because I've not got much space on my board here, so I'm going to need to rub it off. But I'd like you to have it to look at as I go through my answer. Okay, so what does it stand for? Well, the did stands for decimeters, decimeters cubed. So when you get your question, ignore this top question now, I've just written it up so it's ready. So let's start with question 1. When you get your question, the very first thing to do is to change all of your centimetres into decimeters. And I'll go through that in a second. Once you've done that, you need to use a moles equation to figure out the moles of something, anything. It doesn't matter what, it doesn't matter how, you've just got to use one of those. There's only 3 moles equations to choose from, so you're going to pick one of them. So this stands for a moles equation. And the first moles equation always starts moles equals. And there's only 3 to choose from. We've got moles equals mass over mR, moles equals volume of a gas, this only works with gases, divided by 24, and moles equals volume times concentration, and that's for solutions. Now, you'll know which of those 3 equations to choose by looking at the information given to you in the question. So again, I'll go for an example in a sec. Once you've figured out the moles of something, we're going to use our balanced equation to convert that into the moles of something else. So the information they give you here to figure out the moles of something will not be the thing you care about. You'll need to convert that into the moles of the chemical the question asks. SUC stands for sample. If you have a sample or a dilution, now's when you do that. We're not going to do that today. Samples are like a whole hour explanation by themselves, so we're just going to ignore the sample for today. And in actual fact, at AS, it's very, very rare you'll get a sample anyway. I am going to do another video on that eventually, so keep your eyes peeled for that. We then do our second moles equation. Now the second moles equation always starts with the thing you're trying to find out. So for example, in this question here, it says what mass of H2O. So this last moles equation here, the second one, would start mass equals. So the thing you are trying to find out. That's what that starts with. And then the anti, that stands for 2 things. Well, it stands for your answer, but there's 2 things you need to remember about your final answer. The first thing is units. You've got to put the units down, and we'll go through those in a second, but also sig figs, significant figures. You should go to the minimum number of significant figures that the question goes to. But for whatever reason, students seem impossible to remember that. They don't seem to be able to remember that. So you'll actually always get the marks if you go to a minimum of 3 sig figs. So if you can't remember to go to the least amount that the question goes to, just make sure you don't go to less than 3. And you'll notice the question doesn't go to less than 3, 3, 3. So you should always be fine as long as you go to 3 or more. If you go to 4 or 5, you're usually fine. If you go to 2, you've lost a mark straight away. What a stupid place to lose a mark. So that's that. Take a picture of that now to rub out these 3 equations. You definitely need to know those off the top of your head anyway. So this is the word mnemonic we're going to follow through today. So press pause now, write it down, and then unpause now, and you should have that down. So keep that in front of you throughout this little explanation. Okay. So before we start, there's just a few things I want to go through first to do little bits and bobs around the topic, and then we can go on and tackle this question afterwards. So first of all, if I have this equation here, I've got these big numbers in front of my molecule. So for example, I've got 3O2. So just think to yourselves, maybe you could write this down, what do those big numbers mean? Okay, so take a second, what do they actually represent? The fact that that's a 3 and that's a 2, what does that tell me? Now I imagine a lot of you are thinking in your head right now, that tells me I have 3 oxygens, 3 O2s. And that tells me I have 2 carbon dioxides. But that's actually not true. These numbers here, they don't tell you anything about how many moles you actually have. All they tell you is the ratio that you have. So for every 1 mole of this, I will have 3 moles of that. Basically, I've got 3 times as many moles of this as I have that. But that does not mean that I have 3 moles of that, just 3 times as many moles. So if I had, for example, 5 moles of C2H4, I would have 15 moles of O2. And I would have 10 moles of this and 10 moles of that. So it's our molar ratio. If you want to use a fancy word, it's the stoichiometric ratio, ooh la la. But basically it just means the ratio of moles. And this ratio, it only works with moles. So you couldn't do the same thing with concentration. If I had a concentration of 5 moles per decimeter cubed here, these numbers tell me nothing about the rest. So it's only moles that that works with. And that's actually a really important bit, because when we get to the elephant step, the equation step later, we're going to need to use these numbers to convert between our moles. So definitely get that in your head. It's the ratio of moles, not the amount of moles. Okie dokes. So let's go through our, in fact no, first of all let's go through our units. When you get a question, if you don't know what units certain values have, you're going to have no idea what these numbers mean. So, for example, that's centimetres cubed. What does that mean? Is that the concentration? Is that the mass? So we've got to know these things too. So mass in the 3 moles equations should always be in grams. If they give you it in kilograms, you need to change it into grams by multiplying by 1,000. Concentration is always, or has to be always, in moles per decimeter cubed. So again, if it's not given in moles per decimeter cubed, you need to convert it into moles per decimeter cubed. Moles is dead easy, that's just in mole, kind of a unit's that a bit weird, but it's just mole. We've also got volume, and volume is the tricky one. Because in the question, you'll notice in my questions, the volumes tend to be measured in centimetres cubed, but that's not the way you need to use it in the equations. We need to convert it from centimetres cubed into decimetres cubed. So the volume needs to be in decimetres cubed. How do you convert centimetres into decimetres? If you take your centimetres cubed and you divide it by 1,000, you'll get your decimetres cubed. So that's like the relationship. If you wanted to convert it the other way, you'd take your decimetres cubed and you'd multiply by 1,000. But you'll never want to do that because you always want it in decimetres. If you start putting in your volumes in those 3 equations, the moles equations, in centimetres cubed, your answer will be wrong by a factor of 1,000. And that's pretty wrong. So you definitely need to remember to do that. So, let's tackle a question. You might want to pause now and have a go at this question 1 here first. Then when I go through it, you can see where you're going wrong. That might highlight a few misconceptions you've got. So pause now if you want to have a go, and if you don't, we'll just get on with it. So the DID stands for decimeters. So the very first thing I'm going to do is I'm going to go through my question and I'm going to change, actually cross it out in the exam, I'm going to change all of my centimeters cubed into decimeters cubed by dividing by 1,000. And the reason we do that at the very start is because if you try and wait till later, you'll forget. You'll get so caught up in the question, you've got 15 minutes left, what's going on with the question earlier, and you'll just forget to do it. So straight away, I'm going to change this to 0.35 decimeters cubed, and that is my only volume there, so that's fine. Sometimes as well, you won't be given the equation, the balanced equation, as I haven't been here. You'll also need to make sure you've got that. Often they'll give you it, but I haven't here. So I've got H2 and that is reacting with O2, and that's going to give me H2O. So let's balance it. I've got 2 oxygens there, but only 1 there, so I need to put a 2. That now gives me 4 hydrogens, but only 2 there, so I need a 2 there. If you're trying to do a big moles question, without a balanced equation, you'll get it wrong every single time. So draw one down if you haven't got one. And what I would also do, this D stands for decimeters, but sometimes I also like to make it stand for data. So take your data and write it underneath the thing it's talking about. So I've got 0.35 decimeters of hydrogen gas. So I'm going to write down 0.35 decimeters cubed. Now, in a dead simple question like this, it's quite a small question this, it's not that important to do that, but if you've got a half a page question with 6 different numbers in, you can kind of forget what information you know, and then you might need to use something and not realise you already know it. So by ripping it all out and writing it underneath the thing it's about, that helps you spot all the information you've got access to. So then you've got more options for what to do, which is always a good thing. So that's my did step. I have now converted my centimetres to decimeters. Next step, I need to do my moles equation, and the first moles equation always starts moles equals. If you've got that little thing you should have written down earlier, you'll see that. So moles, let's say what it's the moles of. So I'm going to be calculating, well, what can I find the moles of here? It's going to have to be hydrogen, because that's the only thing I know something about. So in brackets, I'm going to put H2. That's got 2 purposes. A, it lets the examiner know that you know what you're calculating the moles of, but more importantly, it lets you keep track of what this number is. And that's the important thing. So which equation am I going to use? Am I going to use moles equals mass over mR? Well, I don't know the mass, so no. Am I going to use moles equals volume times concentration? Well, no, because I don't know them. I do know the volume of a gas. So volume of a gas over 24 equals 0.35 over 24. Using my really good mental arithmetic, I'm going to say that that is 0.01458 ... So there's more numbers there, I'm just too lazy to write them down. Whatever you do, don't round in the middle of a question, or you'll get a rounding error. Only round at the very end when you get to your answer step. So there's more to that, I've just not been bothered to write it down. I would keep that on my calculator and use the whole number. Next step is the equation step. So I found the moles of hydrogen, but the question doesn't ask about hydrogen. I don't care about that. I care about the mass of water. So I need to convert my moles of hydrogen into my moles of water. And I'm going to do that by using my balanced equation. So this is a 2 to 2 ratio. So for every 2 moles of that, I have 2 moles of that, i.e. I have the same number of moles. So here's how I write this down. I would say H2 to H2O is a 2 to 2 ratio. I have 0.01458 ... moles of hydrogen, so I must have the same number of moles of H2O. Okay. If I was trying to find my moles of oxygen, my ratio of hydrogen, and I'm not, but if I was, my ratio of hydrogen to oxygen is a 2 to 1 ratio. So I would have half the number of moles of oxygen that I do hydrogen. So pop that in there, and I've now got my moles of hydrogen. What can I do next? Well, my sample would come next, but we're not going to do a sample today because it's a bit too hard to cover in this video, but definitely watch out for my other video on that, which I'll do in like the next week or so. My next moles equation always starts with the thing we're trying to find out. What we're trying to find out, we're trying to find out the mass of H2O. So mass H2O equals, well, let's rearrange that moles equation from before. So the equation is moles equals mass over mR. In maths, you can take something from the bottom of one side of an equation and flick it to the top of the other, and vice versa. You can take something from the top of one side and flick it to the bottom of the, ow, that really hurt, flick it to the bottom of the other. That's like, Jesus. So I can take this mR and I can flick it to the top, and that gives me mass equals moles times mR. Okay? So feeding in my values, I know my moles, I've just calculated it earlier, 0.01458 ... I know my MMR of water because I've got a periodic table. That's going to be 18. That will give me a final answer of 0.262 grams. Answer, did I put my units? Yes. Have I done it to at least 3 significant figures? Yes. So that would be my answer. We'd get 1 mark for getting here, 1 mark for getting there, and 1 mark for getting our final answer there. If you had to calculate the MR yourself, occasionally you'll get a 4th mark for calculating the MR, but probably not for water because it's a bit too simple. Okay, guys? So that's how we would do moles. I'm just going to pop up another question. Bear with me 2 seconds. Okay, so let's say I've got 4Li plus O2 goes to 2LiO, and it says, what mass of lithium would be needed to make 32.4 grams of LiO. So what mass of lithium would be needed to make 32.4 grams of LiO? So let's go through the whole thing again. So first of all, decimeters, change all my centimetres to decimeters. Always well, pause it and have a go at this using the method now, and then unpause it, and then see if you've got it right to get a bit of practice. So we have no decimeters, so that's fine. My first moles equation always starts moles equals. So what am I going to need to know the moles of? So let's do our data. So I know I've got 32.4 grams of LiO. So which of my 3 equations am I going to use? Well, it's going to have to be moles equals mass over MR, because I don't know anything else. So my moles of LiO, sorry, it should be Li2O. My moles of Li2O, because lithium's got a 1 plus charge and oxygen is 2 minus, so I didn't balance the charges. Yeah, that's why there's a 4 there. So that will equal mass over MR. Well, the mass is going to be my 32.4, and just use my cheat sheet again. The MR is going to be 29.8. So what will that come out as? My mass of lithium, so my moles of lithium will be 1.087 moles. I now know my moles. Let me start that again. I now know my moles of lithium oxide. This is my moles here. Now the fact that there's a 2 there does not mean I need to double this. Because remember, as I said earlier, these big numbers do not tell us how many moles we actually have, they just tell me the ratio of the moles. So if I get an answer of 1.087, that is the answer, 1.087. Don't double it because there's a 2 there. Same with MR as well. When you're calculating the MR, the definition is the mass of a molecule, 1 molecule. So if I've got a 4 here, I wouldn't multiply my MR by 4 or anything like that. It's just the molar ratio. That's the only time we use that big number. So the only time you should be even looking at those big numbers is in the equation step, which is what we're going to do now. So I know about my Li2O. What does the question ask me about? It asks me about lithium. So I need to convert my moles of lithium oxide into lithium. Well, let's look at my ratio. It is a 2 to 4 ratio, which is essentially a 1 to 2, isn't it, basically? So however many moles of this I have double the amount of moles of lithium. That's my molar ratio. So if I have 1.087 moles of this, I'll have 2.1674 moles of lithium there. Just basically double it. Yeah, there we go. 2.174 moles. Sample, well, we're not doing a sample today, but remember that's where it would go. My last moles equation always starts with what we're trying to find out. What's the question asking? It's saying what mass of lithium. So again, the final equation isn't always mass equals. It just so happens in both the questions I've done, that's what it was, because that's what both the questions was asking. So you've got to look at what the question asks for. So mass of lithium, as we said earlier, rearranging, will be moles times AR. I've said AR because it's an atom, not a molecule or anything like that. So that's going to be, my moles is 2.174 times my AR of lithium, which is 6.9. Bang it in a calculator, and I think that comes to, I've got here 15.0. I'm not sure if I've rounded that right. But whatever you get in a calculator for that, that's what the answer is. Make sure it's 3 sig figs, make sure we've got units. Okay? So I've popped up one more at the top there. Definitely have a go at that. And if you look at my next video, which I'm going to release in like a week, on samples, the very thing I'll do at the start of that video is I'll go through the answer to that question. Okay? But you've got 2 examples already here to look at. So that is, did my elephant suck my auntie? And that is moles.